This is the prep packet video for Unit 4, Chapter 9.1. This is the last in the series of the introductory videos on exponents. In this particular video, I'm going to talk about working with exponents and parentheses. So, an exponent that's outside of the parentheses has ultimate power. It rules everything. If I have this one here, x to the third inside the parentheses, and then to the second power outside of the parentheses, that's a set of instructions that tells me to multiply what's inside the parentheses by itself 2 times. So x to the third to the second power is x to the third times x to the third. There's 2, there's 2. And since it's x to the third times x to the third, now how many do I have? I have 6 altogether. And that's why here you multiply what's inside the parentheses by itself 2 times. Or a simpler way to think about it, if I have x to the fourth to the second power, with these two, I get to multiply them because of the parentheses. Okay, so that would be x to the 8th. If it was just x to the 4th times x to the 4th, well, gosh, that's what this says to do. And that would be 4 plus 4 is 8. Excuse me. This works for fractions as well. This particular rational expression is all to the power of 5. So because of the parentheses, I can distribute the 5 both to the numerator and to the denominator. So in the numerator, I'll have x to the second to the 5th power, so that's x to the 10th, and the denominator is x to the 3rd to the 5th power. I'm multiplying them, so that's y to the 15th. Again, it distributes both to the numerator and to the denominator, and only because there's a parentheses am I multiplying. So let's take a look at some to practice, because it makes a little more sense when we see it. So here I have c to the second to the 4th power. Are there parentheses involved? Yes. So now I have c to the 2 times 4, so c to the 8th. Again, I get to multiply because there's a parenthesis, so that's x to the 18th. Here I have x to the 6th to the 1/2. I'm going to multiply 6 over 1 times 1/2 equals 6/2, and don't forget to reduce to 2 goes into 6 3 times. So that's really x to the 3rd. I'm going to save this one and this one till the end, because we haven't quite talked about that. Here I have a rational expression. So I have x to the 2 times 3, so that's x to the 6th over over c to the 4 times 3. So that would be c to the 12th. I can't reduce that because those are different, completely different animals. Here's another one. I have m to the 2nd squared, so m to the 2 times 2, m to the 4th, over g to the 4 times 2, 8th. And again, no can do. Here I have to the x power, so I'll have k to the x times 2, or 2x, over x, oh, here's m to the y, so I'll have m to the x y. Okay, let's go back and talk about number 4 and number 5. Many people are tempted, I'm going to write this in red because it's so important. A lot of people would like to look at this and go, oh, there's x plus 4 to the 2nd. And I've been able to distribute just happy, and they'll try to do x to the 2nd plus 16. And that is wrong, 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 wrong. Don't do it. No, please. Because what that's really saying is take what's inside and square it. So this, let's write this in green so it'll look positive. This is the same as this. And with this, once you get to this point, you would FOIL it to redo, to see what else you could come up with. Same thing with the number 5. Don't make that x to the 4th plus 1 because it's x squared plus 1, whatever's inside, times x squared plus 1. And then you would distribute that and get your answer. So again, these are danger zones. And let me just even go on to say that even more strongly. Danger! Don't distribute the exponent. Not this, yes this. Okay? I can't tell you enough. I even see people in college algebra trying to do that, and I'm just like, don't, you're wasting your time. Anyway, that is the end of the review on exponents, and I'll see you in the next video.